Introduction. The manufacturing technology primarily involves either sizing, shaping, and imparting desired combination of properties to the materials so that the component or engineering system being produced to perform intended application for the design life, right? So generally we will use this manufacturing technology to either size the component raw material or shape the raw material or to impart some desired properties on the raw material which will be fulfilling the intended applications, right? So based on that and based on the approach, this manufacturing process or can be classified into four different types. One is casting process, other one is forming, machining, and joining. While coming to the casting and forming process, that is generally called as a zero process because we are not going to add any material or remove any material from the component, so that we will call that process as a zero process because we are just going to shape, reshape, or size the raw material in these two operations. Whereas in the machining operation, we will remove the material from the raw material to have some desired shape. So since we are removing the raw material from the material, so it is called as a negative process. And finally, coming to the joining process, we are going to add the material over the raw material. So it is called as a positive process. What is joining process? So fabrication of all engineering system frequently needs joining of simple components and parts. For an example, if you take any pipes, we need to join it. We need to put some couplings. When or else you take any engineering applications, we need to join any two structural materials. For an example, our gate, our house gate and all, we will need to join small parts or anything else. Or you take some automobile components, there also we need some joining operations. So this joining is classified into three different types. One is mechanical joining. In the mechanical joining, we will use nuts, bolts, clamps, or rivets. And the second one is adhesive joining, where you will use epoxy resins, fevicol, or any other synthetic resins which is used to join any two components or parts. And finally, welding. So in welding, we will have welding, brazing, and soldering. So this welding is generally used for metallic types, right? So these three types have its own load carrying capacity, reliability, compatibility in joining or similar or dissimilar materials, and also fitness, and also can be used in different environmental applications, right? So we are going to see detailing about the welding in this unit, which is comes under the joining process. So welding is generally called as a permanent joining process, whereas other tools are temporary joining process. When we are applying some force, we can easily remove that component, whereas welding we could not able to remove. What is welding, sir? So welding is a process of joining two similar or dissimilar metals by fusion process. So it joins different metals alloys with or without the application of pressure, or either with or without the use of filler material, where the filler material will be having some fusion operation. So the fusion of metal takes place by means of heat. So generally welding is nothing but the thermal process. The heat may be generated either by the combination of a gas. Using some gases, we are going to generate the heat, or electric arc, or electric resistance, or by the source of some chemical reaction, we are going to generate the heat. So in turns, it will create some fusion operations so that the material will be deposited over the raw material. Whereas in this soldering and bracing, that process don't involve the melting of workpiece, but rather a low melting material. That means either we will use brass or lead, right? So it's melted between the workpiece to bond them together. So this soldering and brazing is generally used for very low melting temperature. That means for IC circuits and all, we will use this soldering and brazing process. Other process and all typically used for some metallic material or non-metallic or any dissimilar materials. What are the fundamentals of welding? So welding, any material need to be welded. The major aspect is it should possess some weldability property. So what is this weldability? What are the factors which depends upon this which depends on the weldability? Means generally we are having some five different factors. One is melting point of a metal, what we are going to be welded, and the next one is thermal conductivity of material. So how good the material is conducting the heat energy. And thermal expansion is nothing but when we are applying some heat energy over the material, it will expand according to the temperature what we are going to give to the material. So that is thermal expansion. This is very important property in the welding because we are going to develop some fusion. So how good it is expanding to it so that it will easily adhere to the neighboring material. And the next one is surface condition. It should be corrosion free. That is, and there should not be any pores or voids. So such kind of a surface condition is very important. And the microstructure, whether there is any change in the microstructure or the micro, we are having the common microstructure throughout the material. So these are the five different factors which always influences the buildability. If these five factors are very good, we will have a very good result in the welding. Why this welding is important? Sir, we cannot skip this welding in our real life, and why we need to weld all the components? Because whatever thing you see in your real life or day-to-day life, everything is welded. So we can many things around us are welded. Starts from pipelines that bring the fresh water to our hose, so that pipelines are welded. And the next one is tower which is used for any telephone applications or internet applications. Everything is welded. You can able to see welded, or we are using some nuts and bolts, right? So also the car, buses, all the automobiles we can able to see, and in the bicycle frame, right? So like that, all the component what we are seeing in our day-to-day life are welded because we need some permanent joining. So that permanent joining can be made by only the welding operation, other than this kind of bolt or nuts, because this is temporary joint. Whenever we need, we can remove that. But the welding is a permanent joint and the cost effective, so that we cannot able to skip this welding in our real life. And where are the applications of the welding? So there are plenty of application, and there is no need of explaining this application. You can able to write whatever application you are seeing in your day-to-day life. Starts from the household applications to the engineering applications. There are a lot of applications for the welding process. Okay, this is very important. How this welding process can be classified, right? So generally we are having about six different types of a welding process. Starts from the gas welding. So gas welding again further classified into air acetylene, oxyacetylene, oxyhydrogen, and pressure gas. Then comes to arc welding. So arc welding, either you will have a carbon arc welding, SMAW, that means submerged metal arc welding, and submerged arc welding, and GTA, gas tungsten arc welding, MIG, metal inert gas welding, electroslag, plasma arc. These are the different type of arc welding. These two weldings are used widely. And next comes very important type of a welding process is nothing but the resistance welding process. This is typically used for thin films. That means sheet metals. You should not say thin film. So this is typically used for sheet metal. Since it is used for sheet metal, this have an application in the automobile, right? So whatever thing you take in the automobile, either it may be a two-wheeler or four-wheeler, all the welding process has been done in the resistance welding. So further in the resistance welding, we can able to see either it is a spot welding, seam welding, projection clasp. So there are a number of types of resistance welding. And next come to the solid state welding. There also we can able to see the number of welding process. And next is thermochemical welding and radiant energy welding. So these are the different types of classifications of a welding process. So generally these three types we are going to see in detail about this in this unit. So how this welding can be classified and how this can be compared? So generally, as I said before, This welding process is nothing but where we are having where we are going to have some fusion operation. So from that fusion operation, we are going to melt the material and we are going to deposit. So that melting will create some joining, right? So that fusion can be happen either using arc or non-arc process. So if you take a gas welding process, there won't be any arc. So in the arc welding process, definitely there will be an arc. So what is an arc means when we are trying to have a positive and negative terminal apart in a small distance, there will be some transport of electrons from positive terminal to negative terminal. So in that case, there will be arc formation, right? So using that arc formation, we are going to fuse the material, right? So we can able to see the different types of a welding. That means a shielded metal arc and the tungsten. So sheeted metal arc we can so the arc this is comes under the arc type of a welding, and tungsten inert gas welding also arc type, MIG and MAG, this and all comes under the arc welding type. Whereas the oxyacetylene and the resistance part, there won't be any arcing, right? So this is a non-arcing type of a welding. And also this won't use the filler wire. That means the filler wire is melted and deposited over the material. So this shielded metal arc won't use any filler wire. Instead, all other process will use the filler wire for welding process, but resistance part also won't use filler wire. But the shielded arc and TIG welding will use the electrodes, right? Not a filler wire. Instead that the electrode it will use, whereas other materials won't use any electrodes, and also the resistance spot welding will use the electrodes. But very important, only the TIG welding process is use both the electrode and the filler wire. So we shall see all the things detailed in the upcoming videos. Coming to these types of the welding position, so generally we will have a four different types of a welding position. One is flat welding. So generally we will have two plates in a table and we will try to weld that. So next one is horizontal type. That is nothing but the welding direction will be in the horizontal manner, right? So the wall and all we are going to weld, no? So we are having a wall. In that wall we are having some plate. In this we are going to weld, no? So that is a horizontal type. If you are trying to weld in the vertical type, so that is a vertical kind of a thing. And if you are trying to weld anything in the roof, the human being is here, right? And he is trying to weld in any roof, that means nothing but a overhead welding. So the difficulty will be increased from the flat welding to the overhead welding. So always this overhead welding is a very tough task, and they need very high skill labor to weld the overhead welding applications. And finally, there are five different types of welding joints. The first type of a welding joint is butt welding. It is nothing but a joining of a two workpiece at the end, so which is not overlap between each other. If it is overlap, that is called as a lap joint. And if you are trying to weld at the edges, right? So at the edges, it is nothing but a edge joint. If you are trying to have a T type of a welding or any fillet, so they will weld here in this portion, they will weld. So that is called as a fillet welding. If they are trying to weld at this corner, right? So at this corner, that is called as a corner joint. So the any type of a welding will be fall on this five different welding joints.